We have another example on the board. The very first thing which I'm going to find is capacitive reactance. So I have X of C is equal 1 divided by omega C. So I have 1 divided by, open parenthesis, 2 times 10 to the 4th power, of course, radians per second, times C, which is equal 10 nanofarads. So my X of C is equal 5 coulombs, and angle of always negative 90 degrees. X of C goes always with angle of negative 90 degrees. Next, we're supposed to realize that we are dealing with the parallel circuit. When we deal with parallel circuit, we're supposed to convert the total impedance to the total admittance, and we have to deal with admittances in order to make this problem looking a little bit simpler. So what I mean by that, we have to find Y total. Y total is equal 1 over Z total. So I have 1 divided by 3 coulombs is equal 333.33 micro Siemens. And please notice that we do not have angle at this moment yet. So next I'm supposed to find the conductance. But in order to find the conductance, I have to find first the capacitive susceptance. So I have BC equals 1 over X of C, which is equal 1 divided by X of C, 5 coulombs, and angle of negative 90 degrees. This is equal 200 microsiemens and angle of 90 degrees. I have Y total, I have BC, I can find G. Formula says Y total square is equal G square plus BC square. Please notice that we are solving the parallel circuit. When we're solving parallel circuit, we're supposed to deal with the admittances. That's why I'm supposed to write this formula. So in order to find the conductance, I'm supposed to solve this formula for G. So if you are going to use algebra, you are going to have G equals square root of Y total square minus BC square. Okay, this is equal square root, open parenthesis, Y total we found is 333.33 microsiemens to the 2nd power minus BC, which is equal 200 microsiemens to the 2nd power (267 microsiemens). Okay, so this is the conductance in my circuit. So next, I'm supposed to find the resistance. So resistance is equal 1 over G, where I have 1 over 267 microsiemens. This is equal 3.74 kilo ohms. Okay, so this is the resistance in my circuit. Please notice that we have resistance, we have capacitive reactance, okay, so we can find total impedance. Okay, of course, there are many other ways to solve this problem, but let's solve this problem using the way with the impedances first. So we have Z total, because this is parallel circuit and I have two components connected in parallel, I'm going to use product over the sum. So I have R times X of C over R plus X of C, where R is equal 3.74 coulombs times X of C 5 coulombs and angle of negative 90 degrees over 3.74 K plus 5 coulombs and angle of negative 90 degrees. So my Z total is equal 3 coulombs and angle of negative 36.79 degrees. So please notice that our calculations are correct because our total impedance is equal to 3 coulombs. So I have 3 coulombs given, okay? So far I'm okay. Plus, I got the angle. Okay, so what you're supposed to keep in mind that if you want to find the total admittance, so you have Y total is equal 1 over Z total, and we found already how much is Y total, which is equal how much? 333.33 microsiemens, and now we can add also angle, because my Z total was missing the angle negative 36.79 degrees, and my Z total is in the denominator, so you have to subtract the angles anytime you divide the two complex numbers expressed in polar form. So your angle over here is going to be positive, so I have 36.79 degrees. So this is my Y total. So we found Y total, we found G, and we found BC, we found resistance. Okay? As I said before, there are many other ways to solve it, but let's start learning these problems using this technique. We can find the total current. In order to find total current, I'm going to use Ohm's law. I total is equal voltage source over Z total, where voltage source is equal 40 volts and angle of 30 degrees over Z total, which is equal 3 coulombs and angle of negative 36.79 degrees. So I total is equal 13.33 milliamps and angle of 66.79 degrees. So this is the total current in my circuit. Next, I'm supposed to find the currents in each branch. Now, please keep in mind that this is parallel circuit, so if it comes to voltage, right, voltage source is going to be equal voltage across the resistor, and this is also voltage equals to the voltage across the capacitor, and everything is equal 40 volts and angle of 30 degrees. So, if I'm looking for current, IR is equal voltage across the resistor over resistance. So I have 40 volts and angle of 30 degrees over the resistance, which is equal 3.74 2.74 coulombs. This is equal 10.69 milliamps and angle of 30 degrees. This is the current which goes through the resistor. Next, I'm supposed to find the current which goes through the capacitor. So if IC is equal VC over X of C. This is equal 40 volts and angle of 30 degrees over X of C, which is equal 5 coulombs and angle of negative 90 degrees. So I have IC equals 8 milliamps and angle of 120 degrees. So this is the current which goes through the capacitor. Next, we're supposed to verify if these two answers are okay. What we're going to use, like always in parallel circuit, we're going to use KCL. KCL, Kirchhoff current law. I total must be equal to the sum of these two currents. So if IR plus IC, where IR is equal 10.69 milliamps and angle of 30 degrees plus 8 milliamps and angle of 120 degrees. This is equal 13.35 milliamps and angle of 66.81 degrees. Now let's check this value and this one. They are close enough, so it means that we are okay so far. Next, we're supposed to find the frequency in the circuit. Please notice that we have given the omega. Okay, formula for omega says omega is equal 2 pi f. If you are going to solve this formula for f, so you'll have f is equal omega over 2 pi, where omega is equal 2 times 10 to the 4th radian per second divided by 2 pi. This is equal 3.18 kilohertz. Okay, so this is the frequency in my circuit. Next, I can find power factor. Power factor is equal cosine of angle theta, angle which is next to Z total or Y total. Cosine of angle negative 36.79 degrees is equal 0.8 lead. Next, we're supposed to find the true power. True power is equal 1/2 voltage across the resistor raised to the second power over resistance, which is equal 1/2, and I have voltage across the resistor, we said 40 volts raised to the second power over the resistance, which is equal 3.74 coulombs. So the true power in my circuit is equal 213.90 milliwatts. Okay, this is the true power. Next, we're supposed to find the reactive power. QC is equal 1/2 voltage across the capacitor raised to the second power over x of c, which is equal 1/2 voltage across the capacitor is equal voltage source, which is 40 volts raised to the second power over x of c, which is equal 5 kiloohms. Everything is equal 160 millivolt ampere reactive. So this is the reactive power in my circuit. Next, I'm supposed to find the apparent power. S equals 1/2, and I have voltage source raised to the second power over Z total, which is equal 1/2, and I have 40 volts raised to the second power over Z total, which is equal 3 kiloohms. This is equal to 66.66 millivolt ampere. Next, I'm supposed to find the series equivalent circuit. So Z total, copy down, Z total is equal 3 kiloohms and angle of negative 36.79 degrees. You're supposed to convert polar form to the rectangular form, and this is equal 2.4 kiloohms minus J 1.79 kiloohms, where the real part is my resistance Rs and my imaginary part is my capacitive reactance X of Cs. The problem is also asking me to find the capacitance in the series equivalent circuit. So I have to use the formula for the capacitive reactance, which says X of Cs is equal 1 over omega Cs. Solve this formula for Cs and you'll obtain Cs equals 1 over omega X of Cs, which is equal 1 divided by omega 2 times 10 to the 4 radians per second times X of Cs, which is equal 1.79 kiloohms. This is equal 27.93 nanofarads. Okay, so this is the capacitance in my series circuit. Next, you can draw the diagram. So I have voltage source with voltage 40 sine omega t plus angle, and I have resistor with the resistance of 2.4 kilo and capacitor with capacitance 27.93 nanofarads. Okay, so at this moment we can say that the problem is solved.